Hello. Hi. So, today we'll be talking about normalization. In the most simplest form, I'll try to explain to you what is normalization and how it works. The idea behind normalization and why we use it, and how we can implement it in our databases. Now, the idea behind normalization is simplicity. That's all. Any database that we want to reduce the redundancy of, so there should not be duplicate anything, actually duplicate rows, duplicate data, duplicate table relations. That's why we normalize, to reduce the amount of data that we are storing, to reduce anomalies like dirty data in a way, right? If there is multiple data, then where to update it, where to delete it, where to insert it, it will raise a lot of questions, and doing these things might might let lead you actually to make bad decisions and have wrong data to print or to update or to calculate with. Now, as I said, reducing dependencies is just making it smaller. Larger tables we make smaller with relations. Now, this thing is to understand that we are increasing as we normalize, we increase relations in a database, which would be kind of like a drawback, but we'll talk about it later. And then we will have a well structured database, every table its own meaning, its own way of doing things, relations with between them. And at the end, if we normalize enough, if we normalize enough and have the proper way or structure, then we will improve the database, its readability, its security, the security of the database, the efficiency of the database will improve. And that's how it will be done. Now, there are four, five, I think six, more than seven ways of database normalization. So this is called normalization forms, which are simply like 1NF, 2NF, 3NF, there's a BCNF, there's 4NF, 5NF, and 6NF, as far as I know. Now, for any kind of industrial thing, these three or these four, let's say, will be, these are kind of rare and niche, you can say, specific to warehousing, specific to data with corner cases in, or conditions with corner cases, right? While these three are most widely used, okay. And the BCNF actually is kind of like the PCNF is kind of like a one thing in middle. It is rare as well, and it is commonly used also. So we'll talk about these four, we'll talk about later on in different videos. Let's say we will see the progression, how data is going through each stage and what we are removing in each stage, in each normalization. For now, we will just talk about these three, which will get you started in the world of database and normalization. All right, so let's go through that. First we have 1NF, simple as that. 1NF states simple these four rules as we have here. The column names should be unique. Column 1, 2, 3, 4. There shouldn't be a column 1 over here again, or a column 2 over here again. They shouldn't be like that. That is wrong. Then every column, all the columns should have atomic values. What that means is every column should, value of each column should be only a single value. So if I have a string value over here, that's it. It cannot be v1, v2, v3. It violates this rule. Now each row should be unique. The entire row as a whole should be different than its peers always. If those two rows are same, that it violates the rule. And this is not generally important, but order is very like not mandatory, not does not matter at all. Moving on, these are the rules for 1NF. Moving on to 2NF, where we eliminate partial dependency. Now partial dependency we have already described in one previous video of ours, you can refer to that. Now simply speaking, you can see that student name is only, sorry, the subject name is only dependent on the subject ID. So what we have to do is this part that we have to remove. So the normalized will become something like and marks, and because this does not depend on the whole composite key here, okay, let's say this role ID and sub ID is a composite key. so it does not depend on that. That's why plus it is this table plus a table with subject id and subject name, like that. That's how we eliminate the partial dependency and we make a relation in between these two tables, which helps us to complete 2NF and normalize the table, normalize the relation. Moving on to 3NF to eliminate transitive dependency. Now here it's kind of important that let's say this is foreign key, this is foreign key, or rather let's say this is a non-key attribute over here. This is just an attribute, okay, and this is another attribute. Now we know if this is a foreign key or a primary key. Let's say we know roll number will get us to subject id, okay, and subject id and teacher are to be connected with each other because subject has a teacher, right? Then we know that subject will give us the teacher. With this thing we know that role can give us transitively, role can give us the teacher value as well. With that in mind, what this becomes after removing this transitive dependencies, because we have to remove this separate alert and we'll have to remove this thing separate, okay. So what it becomes is simply roll number and the subject id, that is the student is learning this subject, and plus the relation with subject id and the teacher, that we know that this subject is taught by this teacher. And that's how the third level of normalization, the 3NF form, is complete. That's how you can normalize the table with 3NF. Now there are many things which are different in case of there are drawbacks. Let's say as you normalize, the thing that will happen is there'll be an increase in what do you call it, relations, which would in turn increase joins. If there are many tables or many relations, let's say if there are many relations like this and there are like joins in each of them, then managing the queries is hard, right? The execution time goes up and the database becomes slow. That's why I said before, if you do a perfect level of normalization, not too much, not too small, not too much, then it would help in efficiency and readability. Otherwise it is just there's a peak, you can say. Let me describe it in that way. Let's say there's a peak, okay, let's say there's a peak. So let's say this is the graph, right, and it's something like this. This is the maximum level of normalization you can achieve. So let's say this is BCNF over here at this point. If you do fourth normalization, fifth or sixth, the performance of the database will go down, right? Performance, and this is normalization, okay. On 1NF it is over here, 2 it is here, 3 it is here, but 4th, 5th and 6th, because this is increasing the joins and the relations and the query time and all, that means the performance will go down, which is wrong. That means we have to do a proper perfect normalization for our database, and that depends on different factors, like what you want to do with the database. What are the operations? Is it reading only, it is writing, it is transactional, it is just storing? What are you doing, using it for? Those decisions are important. Maybe we'll talk about that later when we are designing a database. For now, that's all for the video, guys, and thank you for watching. Get back to me if you have any questions. All right, goodbye.